So welcome to today's lesson in NCEA Level 2 Chemistry. We're going to look at oxidation numbers. So remember right at the start, we were discussing the reaction between magnesium and oxygen in sparklers. And when magnesium lost electrons, the magnesium atom, became positive because it became the magnesium cation. Also, remember, when the reduction of lead sulfate, the lead gained electrons, it became more negative. So it went from lead 2 plus to lead 0, the element. So we already know for a redox reaction to occur, different species have to be oxidized and reduced simultaneously. So to identify which reactants get oxidized and which reactants get reduced, we can use oxidation numbers. So with oxidation numbers, there are a series of rules that you have to learn. So let's go through them now. So the first one is the oxidation number of any element is 0. So if you look at the reaction there of zinc reacting with copper sulfate to form zinc sulfate and copper, a displacement reaction, the zinc and copper are elements, they're metals, and therefore their oxidation number is going to be 0. Rule 2, the oxidation number of any monatomic ion equals the charge on that ion. So for example, when magnesium reacts with chlorine to form magnesium chloride, that means being an ionic salt, it forms magnesium 2 plus ions and chloride ions. So therefore the oxidation number of the magnesium cation is +2, and the chloride anion is going to be -1, because that's the charges they have. Rule 3, the oxidation number of oxygen, being in group 6, is going to be -2, except in the case of peroxides. So hydrogen peroxide will be a case in that. So looking at those compounds there, magnesium oxide, iron oxide, and sodium oxide, in all cases the oxygen has an oxidation number of -2. Rule 4, the oxidation number of hydrogen is +1, except in something called a metal hydride, which we don't really cover in level 2, where the oxidation number is -1. So for all intents and purposes, for this internal, the oxidation number of hydrogen is +1. So for water and hydrochloric acid, the hydrogen forms protons, and these have oxidation numbers of +1. If we did have it in hydride, like sodium hydride, then the hydrogen would be -1. But again, it's a very rare case and not really covered in level 2. Rule 5, the oxidation number of fluorine is always going to be -1. In fact, for the halogens, generally, the oxidation number is also going to be -1. So the chloride and sodium chloride, the bromide and lithium bromide, and the fluoride and calcium fluoride are all going to be -1 and have an oxidation number of -1. And rule 6, the sum of the oxidation numbers of the atoms in a compound always equal 0. The same is also the case for the sum of oxidation numbers in atoms of polyatomic ions. They will equal, the sum will at least equal the charge on that ion. So for example, the sum of nitrogen and the 3 oxygens in nitrate will equal -1, the sum of their oxidation numbers. So in terms of recognizing oxidation and reductions in reactions, so look at the equation as the first step, write out the oxidation numbers for the atoms involved, and when the oxidation of the atom increases, gets more positive, then an oxidation has occurred for that particular species, and when the oxidation number of the atom decreases, it gets more negative, then reduction has occurred for that particular species. Okay, so we're just going to finish off with an example of hydrogen plus chlorine giving 2 hydrochloric chloride as a compound. So in the reaction, which species has been oxidized and which species has been reduced? Well, hydrogen and chlorine both have oxidations of numbers of 0 because they are both elements. Okay, so that's easy. But hydrogen forms an H plus ion in HCl, and the chloride forms a Cl minus in HCl. Therefore, the oxidation number of hydrogen has increased from 0 to 1. Okay, therefore it has been oxidized, and the chlorine has gone from 0 to -1. Therefore, it has been reduced. Okay, so in terms of your internal assessment, you can either use oxidation as being the loss of electrons and reduction being the gain of electrons, or you could say, well, using oxidation numbers, a species oxidation number has gone down, it's been reduced, and if it's gone up, become more positive, it has been oxidized. Both are acceptable.